So I'm going to give some context. I'm going to anchor what I mean by identifiers when I talk about DIDs. And then we're going to use verifiable credentials in contrast with NFTs to explain how DIDs have unique roles for both of those opportunities or both of those technologies. I'm going to introduce something called interchain identifiers, which is a family of DID methods. And then I'm going to walk through the requirements of those methods as a way to explain the business requirements that we can meet using DIDs with NFTs. So who am I? I'm Joe Andrieu. I run a small boutique consulting firm called Legendary Requirements. We focus on decentralized identity systems, specifically doing requirements engineering for that, which shouldn't be surprising given the name. I am an invited expert at the World Wide Web Consortium on a number of topics, mostly focused on developing use cases for the verifiable credentials, for the DID use cases, and the upcoming VC API. And I'm also the creator of the DID method rubric, which is a way to evaluate different DID methods. I'm also the board member, treasurer, producer, facilitator. I'm in up to my eyeballs in something called Rebooting the Web of Trust, which together collectively over a period of about 5 years, we published 50+ papers on decentralized identity. And finally, I'm the host of The Rubric, which is a podcast about DID methods and method creators and implementers. I got dragged into the world of NFTs about 1.5 years ago. I'm currently the requirements lead for the Earth program, and that is funded by the Interchain Foundation and led by IXO, which is both an application chain and a company. And they brought me in to specifically figure out how do we add DIDs to NFTs for the Cosmos SDK. So this is one of many possible platforms for developing blockchains. And what IXO does is they have something called impact tokens, which map verifiable Earth state to chain state. Another way to think about that is they use verifiable credentials, which can be certified and independently verified, not just as a VC, but the fact that's asserted in the VC, to automate policy-driven NFTs. So one example is the UN FCCC could come in and create a renewable energy certificate NFT and use this framework to semi-automate the creation of those kind of, well, as IXO calls them, impact tokens. So I want to anchor with something that might seem really obvious, that DIDs are identifiers, and they're used to refer to specific things. And if you're using the same identifier, that means you're talking about the same thing. In other words, VCs, verifiable credentials that have the same subject ID, are taken to be statements about the same entity. Now, there are always errors, whether it's in the assignment of the identifier or the interpretation of the identifier, but DIDs as identifiers can fulfill several unique functions with NFTs. And I want to anchor that it's about how you refer to things. And I'll explain what that means when we walk through the requirements. So let's talk about VCs. This is the first part of my contrast and compare to explain what NFTs are and how DIDs work with that. DIDs for VCs enable a particular form of cryptographic identity assurance. And they do that first well, they do it in 3 steps. The first step is you onboard the issuer you onboard the user at the issuer's app. And that includes creating an authentication mechanism. You can give them username and password. You can use some other mechanism. You can even have them log in with Facebook if that's how you want to secure that first app. Once you have that account and that mechanism of authentication, you can then perform initial identity assurance. So in some communities, especially financial institutions, this is known as know your customer. And now you know for some level of quality who it is that has that account that can be authenticated into. Step 2 is before you issue the actual VC, you first have the user authenticate into that app. And then you use some form of DID authentication or DID auth to prove control of a particular DID. And now that we've proven control of that DID, we can issue a verifiable credential with that DID as a subject. And you get bonus points if you record that DID auth as proof, either as evidence directly in the VC, or you could have a hash of the auth in that VC, or you could just store it on server side so that the issuer has a record that in fact the user had proven control of that DID before it was used to identify them. And step 3 is when the holder is ready to share that verifiable credential with a verifier, they sign a verifiable presentation. And if they do so using the same subject DID that was previously authenticated, then magic starts to happen. They send that signed verifiable presentation to the verifier, and now the verifier can verify the signature on that verifiable presentation, which proves that the current user has control over that same DID. They can verify the signature on the verifiable credential itself, which proves that the credential has been untampered with since it was initially created by the issuer. And finally, if it is included in a mechanism they can get access to, they could also check the DID auth proof, right? They could verify that, yes, this credential that I'm relying on had an initial DID auth ceremony. Now, I don't know of any deployed systems that are using it, but this is an approach I recommend to all of my clients right now, because then you get 2 steps of cryptographic assurance that the presenter at this stage in step 3 is in fact the same party who initially received the VC. Now, if the keys were stolen or something like that, you don't have that assurance, but cryptography is based on this ability to keep secrets secret. So I believe this is a much stronger assurance than you could have with username and password and with other 2FA forms. So this particular 3 steps allows verifiable credentials to have a cryptographic sense of identity assurance. Now, as I mentioned before, there can be errors, so it doesn't solve all the problems in this space. There could be bookkeeping errors at issuance. There could be social engineering where someone talked someone at the company, at the issuer's company, into doing something inappropriate. That could be through customer support. It may not even be a friend. Or there could be a technical hack, right? Something that wasn't about human engineering, it was about technical engineering. Could be stolen keys, could be getting access to the system and updating the database internally. And then on the other end, there are also possible errors in terms of misinterpreting what those claims mean, or perhaps trusting the wrong issuer. So you might get a claim that someone has a license to drive, but it's not from a legitimate Department of Motor Vehicles or a similar entity. So because VCs are so powerful in that they can allow anyone to say anything about anyone or any specific entity, you could literally say anything with a VC. So why not use them for authorization, for delegations, for NFTs, for anything? Well, there are good reasons. Verifiable credentials are what I call Chomsky complete, which is a bit of a nod towards Turing complete, which is a computational term. VCs are statements. And so anything that can be done using language could be done with a verifiable credential, right? So anything that you can say in language, which Chomsky nailed, and then Gödel actually explained how there are fundamental limits to every language. So we can't say anything, but anything that could be said by language, which is a pretty big set, you could put in a VC. So of course, you could make a verifiable credential that represents an authorization, or you could make a verifiable credential that represents delegation. However, it doesn't mean that you should. And that's because of semantic ambiguity and semantic drift. What the claims mean when they are created may shift over time. Words, the meaning of words change. And the meaning of words when issued by an issuer could be different than what the verifier interprets it as. So these are all areas where ambiguity can create errors. And if you set up an architecture that uses chained VCs, these errors multiply. It's like playing a game of operator if you use verifiable credentials in that way to do things like authorization, delegation. In short, you get different guarantees from different approaches. And so you want to think closely about, or think deeply about, what guarantees are actually important here. So let me talk about VCs and NFTs. So VCs are verifiable assertion by a deterministic author. They're not guaranteed to be unique. They're not expected to be transferable. In general, statements aren't transferable. So you could have a VC that basically says, Joe said the sky is blue, and I signed that with my DID, and now you have this statement. Well, what does it mean to transfer it? If you give it to someone else, it doesn't mean that, you know, if I give it to Tom, it doesn't mean Tom said the sky is blue. The statement is still Joe said the sky is blue. So in fact, sometimes it's even hard to know when is that particular statement is appropriate. Does it mean the sky is still blue? So there may be context that's necessary to understand the statement. And second, the underlying claims represented by that verifiable credential may not be transferable. The verifiable credential use cases were based on things like college degrees, passports or driver's license, vaccination records. Thank you for the note to speak slowly. I will attempt to slow down. I get excited and I talk very fast, so thank you for that note. So the underlying claims in most VCs may not be transferable at all. It may not make any sense. So what we have at the end of the day is that verifiable credentials are verifiable statements by a knowable author. NFTs, on the other hand, are rivalrous digital goods. That means they're unique, they have provable ownership, and they're secure transferability. And this is from cryptocurrency solving the double spend problem, initially with Bitcoin, and then other chains have figured out additional ways to do it. But that preventing a double spend is core to NFTs. It means that transferring the bits does not transfer ownership. So yes, you could copy the JPEG of your CryptoKitty, but that doesn't mean you own the CryptoKitty. So the secure transferability is where you get that economic notion of rivalrous. And these are two very different things between verifiable credentials and NFTs. So they both happen to use cryptography to enable independent verification. That's where we get in the self-sovereign notion and this decentralized notion. But VCs verify authenticity and timeliness. You can check that it's tampered and you can check that the status is still valid. NFTs, in contrast, verify uniqueness and they verify transferability. So VCs are great, but they're for different uses than NFTs. And DIDs can play a similar but distinct role in the two. So let's get into what DIDs can do with VCs. I'm sorry, with NFTs. Okay, in my work with Cosmos, we came up with a new family of DID methods that were designed specifically for referring to on-chain assets. Now, classically, DIDs can be used to refer to anything, people, organizations, abstract concepts, as well as on-chain assets. But we found that thinking about DIDs in a general purpose solution didn't help us solve the problems that are unique to NFTs. So we said, hey, well, what if there was a family of methods that all had supported a common set of properties, a common set of capabilities. So IIDs are 100% DID compatible. IIDs are DIDs in the same way that the side tree family of DID methods allows DID methods, multiple different DID methods on different verifiable data registries to use the same architecture. IIDs allow any DID method that supports the IID framework to be an IID method. We do have two major new properties that I'm going to introduce right here: linked resources and accorded rights. And IIDs, like DIDs, are fundamentally chain agnostic. In fact, they're agnostic to any sort of verifiable data registry. Of course, when you're talking about NFTs, we're mostly talking about blockchains or some other sort of distributed ledger. But since it's a family of methods, you can, for just about any compatible verifiable data registry, you could come up with an IID method that supports IIDs, that supports DIDs, that works in the way that we're talking about here. So the first major property that we added to the DID gestalt is something called linked resources. And this is a way to identify resources that are linked to that NFT or that on-chain asset. So it allows privacy enabling verifiable resources. There are actually 4 different ways that you could link to a resource, from embedding it directly in the DID document to referring to it by hash. And this sort of spectrum allows a variety of ways to be compliant with GDPR or other privacy concerns. It happens to fix HTTP range 14, which, unless you're a geek in the audience, that probably doesn't mean anything, but you can Google it. It's a very sort of interesting problem of the semantic web. And we solve it with this notion that we defined IID resources, which are downloadable. So by design, this particular DID URL you see in front of you, DID example abc/image.png, theoretically could be put directly as the value of a source attribute in an image tag in an HTML page. And if your browser understands DIDs and understands IIDs, then that image would simply get rendered in the browser. Now, no browsers do this today. This is very forward-looking technology. The second part of this is we create these IID references where nearly the same did URL, except with a hashtag. So did example ABC hashtag image.png. That is a way to refer to that image and to have a conversation about it, what its size is or what its hash should be. And that's a way that you can guarantee that, in fact, when someone gets the image, they can know that they are getting the correct image. So these linked resources are useful for identifying, providing directly, giving access to these resources, and verifying things like evidence. Like, why was this NFT created? In the case of the impact tokens for ICSO, we're looking at evidence of a project that meets a UN standard and that had a verifier come out on site and test that the certified project was in fact deployed and in operations. And so that's a form of evidence that can be linked to from the NFT. We can also link to associated assets. Earlier, I mentioned the image that you might have with a CryptoKitty or similar art or collectible NFT. Those sorts of associated assets can be linked in this property of linked resources. The other major property that we created is called accorded rights. And that specifies the rights or privileges that are accorded to the asset owner or their agent. Right? So with an NFT, we're talking about if you own this NFT, what do you get to do with it? What do you get because you own it or because the owner has delegated to you some sort of privilege? This removes the ambiguity about intellectual property rights licensed to NFT owners. Right now, there have been lawsuits and kerfluffles over NFTs that were purchased and then used in a different medium. For example, printed out and put on the wall. It's not clear that the original license to that NFT explicitly allowed that purpose. And so then it gets into a legal conversation about, well, is it fair use or did I get everything? It's kind of a mess, this intellectual property problem. It also, because you're being explicit about these rights, enables derivative and bundled rights. So that you could take, for example, a property that you have all the rights in all media in all of the world, and you could break it into rights in different media, perhaps even slicing that even further to say the rights in Korea versus the rights in North America and the rights in Japan or Russia or Europe or South America. And then you could bundle those back together to create another NFT. So it provides a flexible way to be explicit about those rights that travel with ownership of the NFT. And then finally, the accorded rights also allows delegation without transfer. So because DIDs can provide a way to invoke and delegate capabilities, those are two of the verification relationships that are possible in a DID document. We can also use accorded rights to delegate those particular accorded rights to another party, another cryptographic identifier. Okay. Now, the rest of my talk, I'm going to walk through the requirements that we put together. We had about 6 months worth of workshops with weekly calls and talking to people with various different use cases who had different reasons and different needs for NFTs. And with that, I was trying to figure out, well, what do they really need about identifiers? So we came up with 12 affirmative requirements. Oh, and there's a lovely typo, and 1 negative requirement. So we captured all of this at this URL. So if you get the PowerPoint, you can go there directly. That was the first stage of our work that we did about a year ago. And then I'm just going to walk you through those 13 requirements. The first one is we need to be able to identify on-chain tokens. Right, so this is the primary purpose. We want to be able to have a unique identifier that specifically points to that asset. And we need to be able to specify which chain is it on or which network is it on, potentially even which fork it's on. And some DID methods don't handle this well, but it's within the DID method framework that you could specify which fork of Bitcoin versus BCH, ETH versus ETH Classic, etc. Our point here is we need to be able to enable unambiguous interpretation of what asset we're talking about, because that's the core thing, is we want a decentralized identifier that can refer to that specific NFT without ambiguity. And our solution is that by convention, all IIDs only refer to on-chain assets. The IID methods themselves define the create, read, update, and deactivate methods or operations for any verifiable data registry. So whether you're on Ethereum or Bitcoin, you're on a particular smart contract on Ethereum, or you're on Cosmos or Polkadot or Solana, you could come up with an IID method that would support that particular framework. So it's definable for any type of asset that is on chain. So that could be a UTXO, which is how Bitcoin talks about unspent transactions. It could be an account. It could be a smart contract. It could be an NFT. Requirement 2 is we need to be able to identify off-chain resources. So NFTs often need to unambiguously refer to digital and real-world resources. So some of the use cases that were part of our mix in our conversation is a NFT that's a theater ticket. Well, it needs to define what performance is that a ticket for, as well as maybe what seats or its general admission or those sorts of things. We had NFTs that were property titles. And for example, for a plot of land, well, you need to define what's the plot of land. And you may need to provide additional assertions about things like easements, liens, or permits. These, of course, can all be associated with linked resources. And the digital collectible, a CryptoKitty or a piece of NFT art, its visualization needs to be specified, perhaps by a content-specific hash, that you can get from IPFS. Of course, there are lots of ways to do that, but the requirement here is that we need to be able to refer to these off-chain resources. And our solution is linked resources, which I walked through before, and in particular, IID references. Let us create NFT-specific identifiers that you could think of as being within the namespace of the IID. So you have this NFT, and you can create any number of identifiers that only exist, or at least are defined within that NFT itself, within the notional sense of that NFT. The other thing is IID resources, which link to digitally verifiable assets that you can download. So you put an IID resource in, and that means somewhere, we should be able to download that PDF or that PNG or whatever format that resource might be in. Requirement 3, we need to be able to work with any chain. That allows cross-chain operations where one chain is working with assets on another. This is a huge emerging area in the Cosmos world. They have something called the Interblockchain Communications, IBC. There are other approaches that use bridges. This is a very hot topic of development, and IIDs have to be able to support that. It also needs to be able to support off-chain operations, so that if you have a decentralized application, a DApp, as it is often called, that DApp can operate with any supported chain. So that starts to get into a way to enable multi-chain functionality because we have a common identifier format. Our solution is that we come up with custom IID methods for any asset on any chain. We use the did method pattern. Each method would create its own operations for create, read, update, and deactivate. And the details required for each chain or for each asset are defined in those methods. And so all IID conformant did methods are also IID methods. Requirement 4, we needed to be able to enable verifiable assertions or verifiable credentials, but really it could be any kind of assertion. And so the identifiers for both the on-chain and the off-chain assets have to be suitable for this kind of use, these verifiable assertions, and they should work the same way, whether they're offline, online, or some sort of hybrid situation, because maybe you're only temporarily online. And they must be usable for verifiable credentials. So this one was particularly easy. In fact, a lot of these requirements are easy because IIDs are DIDs, and DIDs are natively supported for verifiable credentials. So IIDs and IID references are DIDs and DID URLs or DID URIs, depending on how you want to talk about it. And they are universally self-describing. So they can be used in nearly any system of assertions. Requirement 5, we need to be able to enable both private and public assertions. And that means we have to be able to support publicly revealed assertions that anyone can see. And we need to be able to have privately verifiable assertions that maybe are only available to authorized parties. And our solution to that is a combination of verifiable credentials that are linked or unlisted. So they could be listed as a linked resource, where we literally publish the VC. We could have a public endpoint and the DID document points to that and you can go and download it. It could also be listed but not published through the DID document. So maybe all you have is a hash. But if you can get the actual VC, I'm sorry, I misstated that. So these are unpublished, but we know they're associated. So you can get them somewhere. They may not be in the DID document itself, but we have the hash, we have the provability within the linked resources. The next category is unlisted. That could be privately created and communicated. So I could take that identifier for an NFT, I could make an assertion about it, and I could communicate that privately. We can also use the cryptography in the NFT's DID document itself, in the IAD document, so that the NFT could sign a statement that can be privately verified. And since it's signed by the NFT, you can know, yes, this is the VC that we were talking about. These are the sets of claims that are provably associated with this NFT. Requirement 6, we need to be able to verify that we have all of the information needed to make a decision about using or purchase that NFT. So if you're looking at an NFT and you're an OpenSea or somewhere else, some other NFT market, how do you know that you can actually get to the image? Or how do you know that you can read the information about the easements or the liens or other sort of encumbrances on an asset? An art NFT may need that visual asset. It may need a statement of authorship. It could have a certificate of authenticity. Property titles, I've mentioned a couple times, could need statements of liens and warranties and easements. This data may not be suitable to put on chain because of GDPR or other privacy regulations. You really don't want to be putting people's names and addresses on chain. And so this is an approach that can get us beyond that. So the solution is linked resources, which allow these inline and off-chain publication, and you can verify regardless of whether or not it's published. So as long as you can get a hold of the verifiable credential or the associated assets, because you're in a legitimate sales conversation with the person who actually owns the property, then you can verify that you have all the assets you need and move forward with the purchase or decide, one way or the other. So all those disclosures, terms, and resources can be linked directly from the DID document. Okay, requirement 7 is offline creation of identifiers. This was a late addition in our conversation, basically because there are some DID methods that introduce this technique that's pretty brilliant. So not all blockchains can support it, or at least not all DID method approaches for given blockchains support it. But if you can, then it has to be possible to create these identifiers offline. And that means creating the crypto, well, I'll get to that in the solution part, but when you have it, it means that you can sign the linked resources even prior to minting. So you may want to have a VC that is linked to from the NFT that you're about to create, and it can be signed by the identifier for that NFT. And that also allows minting from a signed transaction. So the NFT can, on some notion, mint itself. And that is the solution, is you cryptographically create an identifier. It could be a public key. It could be a public key with a hash. It will all depend on the method that will, and which depends on the underlying verifiable data registry. You have to use a cryptographic curve that is compatible with that chain, of course. But once you create it, now you can submit a signed transaction to create that on-chain asset. Now that asset construction or minting process has to know how to do this. So you probably can't do it with any current NFTs. But the folks I'm working with at IXO and Interchain are looking towards this opportunity. And the way it works is when you have the IID or the DID from DID methods that have this approach, you first check the chain for resolution. And if that does not have a DID document, then you go back to the deterministic method based just on the information in the DID. Requirement 8 is the ability to use IIDs with self-sovereign identity approaches. We want it to be compatible with DIDs and verifiable credential wallets. And we want individuals to be able to manage their own identifiers and cryptographic secrets. That was key to this work. And we mostly get this for free because IIDs are DIDs. So DIDs are created hand in hand with SSI. They're widely used for SSI. And DID technologies will generally work with IIDs. It's the same syntax, same resolution approaches, same data formats. There may need updates to support these new properties that I've mentioned here. But in the scheme of things, we're leveraging as much as we can of the existing infrastructure and architecture. And then IID references, which allow this sub-NFT SSI compatible ID, allows authentication, assertions, and delegations for people and organizations. It's not the ID itself, but these ID references can enable individuals to log in as the owner of a token or access a theater show or whatever the NFT is accorded, really embodying SSI capabilities because they own this NFT or they were authorized by the owner of the NFT. Requirement 9, we wanted to be able to work with confidential storage. There are several emerging approaches to that. I don't know if these 3 should still be called 3. I think it's just 2. There's secure data storage, encrypted data vaults, and confidential storage, all of which I think are being championed over at a DIF working group that used to be called secure data storage, and I think is now called confidential storage. And what that requires is we need cryptographic forms of authorization, and we need to be able to encrypt and decrypt with these identifiers. Again, we get this almost for free because IIDs are DIDs and confidential storage is developed with DIDs in mind, and DID technologies work with IIDs, right? This is sort of a repeating refrain here. And IID delegations can allow authorized access to these confidential data storage services. Requirement 10, recognizability. IIDs had to be recognizable as such. They have unique properties compared to other, bits of strings. I'm sorry, bit strings, strings of bits. So when they are used in different contexts, we want it to be clear that the identifier is an IID. One of the things that happen when you look at Bitcoin transactions or Ethereum transactions is that identifiers can kind of get all bundled up in a very compact form, and so that they could be concisely recorded on chain. But we wanted to make sure that we weren't losing the bits because they weren't well labeled or weren't self-describing. So again, IIDs are DIDs, which are URIs. And URIs, Uniform Resource Identifiers, are self-describing. They use the scheme part to specify the type of identifier, right? That's HTTP for World Wide Web links, mail to for email links, and DID : of course, for DIDs. So like DIDs, the method part of the IID specifies what kind of IID it is. And then in each IID method, in each IID method specification, we get clarity about how the method supports these different IID conventions, these new properties that we've come up with. Requirement 11, we need to be able to support multiple metadata representations. So by metadata, we mean all the stuff that comes with the control structure of the on-chain representation of who owns this NFT. And we needed to do that in a variety of formats, whether it's a PDF or a PNG or something else, and we need to do it without losing rigor. And we needed to be able to do it on any blockchain. And this includes representations of those associated rights and attributes. So those rights and attributes could just be represented as claim language in a verifiable credential, or they could use a more sophisticated architecture, or they could just be a PDF of a signed contract or a PDF of a terms of service or something of that nature. Of course, we do this with linked resources, which separates that metadata from the on-chain asset control mechanism. So you can list in the linked resources exactly whatever you need. You can link to a PDF, a PNG, you can link to RDF XML, and you can use content-based hashes that can be verified for any digital object, regardless of the format. And of course, on-chain metadata can also be supported with our approach with linked resources. You could directly embed certain information when appropriate on-chain. And the last affirmative requirement is that we wanted to leverage existing tooling and infrastructure. So nouveau tools based on proprietary new approaches can be quite problematic to work with. So we wanted to leverage mature tools as much as possible to reduce risk, to increase interoperability, to support as many platforms as possible, and to actually have the reliability to trust this platform for high value transactions. Mostly, we're leveraging the fact that IIDs are DIDs and those are URIs. So DIDs are new, so it's maybe a little bit aggressive to claim that, oh, yay, we're getting mature DID tooling, but we do get to use existing DID tooling. So that is a leg up. And both DIDs and IIDs as URIs leverage tools and infrastructure of the entire World Wide Web and the semantic web. And then finally, our anti-requirement is human readability. What's important for these is to be able to uniquely identify that asset on chain. And it's important to do that in a decentralized way and as securely as possible. And that's more important than having a human-friendly name. So you don't get to own an NFT whose identifier is, Nike.com or Michael Jordan or something like that, because that's not how we chose to make these identifiers work. In fact, attempting to make decentralized and secure identifiers also human-friendly is often believed, well, I believe it, and others believe it's believed to be impossible. Something called Zuko's triangle. You can Google it and see that those three elements are a trilemma that is well documented and discussed. And we chose decentralized and secure over human readability. And that's easy. Again, because IIDs are DIDs, and DIDs made the same design choice. So we are expecting that the identifiers use cryptographic creation, so they're not in a first to claim dynamic like you have with the domain name system, where of course, getting the right to control which website responds to Nike.com is a very valuable proposition. We're not dealing with that world whatsoever. However, registries, directories, and other human-friendly mechanisms can be added on top of those IIDs. So having a unique cryptographic identifier, you can move on to build those types of systems on top of that. So that takes me through the bulk of my presentation, and I think I just have a closing slide for questions. And so that's it.